Welcome back. In this video, we are going to discuss about the need of additional heaps. So let us see what are the motivations behind the use of additional heaps. So the first motivation is that we want to protect a memory block which can be corrupted by some other memory block of some other data structure. We will discuss that in detail. Then we can address the fragmentation issue as well. In case of fragmentation issues, there are some unused memory blocks available to you, but still your program cannot use it. So this fragmentation issues cause the inefficient memory uses. Then the third motivation is that we want to avoid the thread synchronization overhead, because if there are two processes and if they both are trying to allocate the memory, or you can say if there are two threads in your program and if both of them are trying to allocate the memory on the heap at the same time, then one of the threads will be stopped until the other thread is done with the memory allocation. So this thread synchronization is also a performance overhead. So with the help of additional heaps, we can minimize these synchronization issues. So better performance can be confirmed. The last motivation is the quick free operation. In case you are using a single heap and you are using different data structure to allocate the blocks of memory on the single heap, then if you have done with the one of the data structures and you don't need it anymore, then you need to remove the blocks one by one and you cannot destroy the entire heap. So the free operation is a bit slow. But in case of additional heaps or the dedicated heap for a particular data structure, you can do it faster and you can destroy entire heap as soon as the entire data structure is of no use in your program. So let us discuss first about the protection of memory blocks. Suppose there are two types of memory blocks in your program that you are going to use. Say block 1 and block 2. Suppose block 1 is for tree and block 2 is for linked list. And you have only one heap. So block 1 and block 2 nodes will keep allocating on the same heap. At some moment, it may happen that block 1 or block 2 could possibly override the other block. That is, block 1 may corrupt the data in block 2 and vice versa. This type of error at runtime will be very hard to diagnose. So we can understand it in this way. Suppose you have this area. You have block 1 and you have block 2. Suppose in block 1 you are using some array, or you can say you are using some of the strings, and you write on the string which is more than the allocated size, and hence it moved to B2, or you can say it moved to B2 block area which was already allocated. So it will corrupt the data in B2. So this is what we are explaining here. The additional heap will resolve this problem as it will be dedicated to one special type of block only. Now let's see the fragmentation issue. Consider two types of memory blocks in your program, say block 1 and block 2, against the two different data structures. Suppose one is used for tree and the other is being used for linked list. Now suppose the size of block 1 is 24 bytes and the size of block 2 is 32 bytes. Now, since you have only one heap, then memory will be allocated for these blocks, block 1 and block 2, on the same heap. At some point of time, there could be a situation where there is a free space of less than 24 and 32 bytes between two nodes. This free node is of no use, as none of these nodes can fit into this free space, because you already know that the block of memory is allocated contiguously. If 24 bytes are needed, then contiguous memory of 24 bytes will be needed on heap. So if there is less memory which is not equal to 32 and not fitting for 24, then in that case that particular memory block will keep dangling and no one will be able to claim in your virtual address space. So this is called the fragmentation issue. So let's see it with an example. Suppose you have 60 byte of space. B1 or block 1 takes 32, or you can say 24, and B2 is taking 32. So total became 56. Suppose you had 60 bytes of space on your heap. Now, since 24 and 32, they have utilized 1 and 1 block each. Now, the remaining 4 bytes cannot be claimed by any of the B1 or B2. I am using B1 for block 1 and using B2 for block 2. So this way, this 4 byte will remain unused. This is just an example. There will be many such chunks which will remain unused, and this fragmentation issue will lead to inefficient memory management. But with the additional heap, this memory utilization issue will be fixed, because every time same size block will be there and you will commit the size of the heap initially which will fit into your needs. So there will be no fragmentation issues. The other two motivations are avoiding the synchronization and the quick free. Let's see the avoiding the synchronization thing. Only in certain cases, as one specific data structure can be specific to be handled by one thread only. It may be that in your program, there are certain threads which are handling one specific type of data structures. In that case, that thread doesn't need to be synchronized, or you can say it doesn't need to be serialized. So you don't need to worry about the synchronization or the serialization. The serialization is automatically done on the heaps. So if you are using a single thread for a single data structure, then in that case, this synchronization overhead will not be done. And this synchronization overhead can be avoided, and hence a better performance can be ensured. Now let's talk about the quick free. It's the same as I discussed in beginning. So in case of a single default heap, block by block free operation need to be performed. But if there are two types of DS, say block 1 and block 2 to be allocated on heap, then if block 1 need to be removed, it will be like removing one by one and not the entire heap can be freed up. But in case of additional personal heap dedicated to a single data structure to be managed, entire heap can be deleted once the use of that data is no more needed. So I hope you might have got the point that why the additional heaps are used. That's it. Thank you.